Okay, hey guys, we're going to start this episode off a little bit differently because I've received a question through my YouTube messages. Someone sent in a question. Now, what I thought I'd do, I haven't actually looked at his question yet. I just printed it off straight away without looking at it, and I thought it might be sort of interesting learning exercise if you see me read the question for the first time and then I'll handle the maths straight away, and we'll see how that goes. So hopefully you'll get to see how I deal with something I haven't seen for the first time as well. So I did see her name. It's from a question from Sally from Berwick-upon-Tweed. And Sally, let's see what she says. So, So Sally said, how can you expect us to revise for this FP2 exam when you clearly put no effort into making your videos? Wasn't really expecting something like a question like that. I'm a hypocrite, I guess would be the answer to that. Yeah, okay. Well, thanks anyway, Sally. Yeah, okay. Let's get on with it. It's looking at a really old one, a blast from the past today. JAN06, FP2 still, AQA. And I'm going to record I'm going to do two questions. I'll probably do them in two separate videos though. We'll see how it goes. And the first question, they're not both on complex numbers. The first one's on complex numbers. Question 6. So JAN06, FP2, AQA, question 6. Get that out in front of you. Complex numbers. So first of all, it tells you that Z is equal to e to the I theta. So this is question 6. And they want you to find what z plus 1 over z is. So z plus 1 over z. So it's a little bit difficult to do anything with 1 over e to the I theta unless you bring that up to the top and make it a power of minus 1. So let's write it out like that. And now I know what e to the I theta is to the power of minus 1 because you just multiply your powers. So this is e to the I theta plus e to the minus I theta. And we want that to be cos 2 theta. So that gives us quite a big clue that we're going to have to write this out in sine and cos form, or cos and sine form. R times cos theta plus I sine theta. There is no argument here. R is equal to 1. So e to the I theta is cos theta plus I sine theta. And e to the minus I theta would be cos minus theta plus I sine minus theta. And I'm not going to spend too long talking about this because I did in one of my previous videos. But because cos is symmetric about the y-axis, cos theta equals minus cos theta. No, it doesn't. Cos theta equals cos of minus theta. And because sine is not really symmetric, it's kind of flipped, that means that sine theta is equal to minus sine minus theta. So it's a trick you see a lot with these kind of complex numbers, that sine theta and sine minus theta cancel each other out, and the coses combine to give you 2 cos theta as required. Lovely. Next question. I'll rub it all out and start again. Right. Next question is z squared plus 1 over z squared. And again, we can't do anything with 1 over e to the I theta squared, so we're going to bring that power up to the top. So z squared plus z to the minus 2, and that equals e to 2I theta plus e to the minus 2I theta. And then we use exactly the same trick as before. Really easy, 4 marks actually, beginning of this question. So that would be cos 2 theta plus I sine 2 theta plus cos minus 2 theta plus I sine minus 2 theta. And just like before, the sines cancel out and the coses combine to give you 2 cos 2 theta. Nice and easy so far, 4 marks. Does get harder. Okay, part 3 then. We're just stitching those 2 parts together really because they want an expression for z squared minus z plus 2 minus 1 over z, I'm going to write that as z to the minus 1, plus 1 over z squared, again I'm going to write that as z to the minus 2. So what have we got here? Let's rearrange it so to get parts 1 and parts 2 out of it. So part 1 was z plus 1 over z, and we can take the minus out of that. And part 2 was z squared plus z to the minus 2. So that's our answer to part 2. And then let's take the minus out to get our answer to part 1. So z plus z to the minus 1, minus outside the bracket, and then plus 2. So what did we get for part 2? That was 2 cos 2 theta. And for part 1 we got 2 cos theta. And then plus 2. But that isn't quite what the answer wants. The answer doesn't have any expressions involving cos of 2 theta. So we're going to have to get that using the double angle formula to something involving cos theta. Now, double angle formula is in your formula booklet, so you can just look it up, cos A plus B. If you whack cos 2 theta into that, so cos 2 theta equals cos squared theta minus sine squared theta. But the answer doesn't have any sine squared thetas in it, so we're going to want to get rid of that sine squared theta. Sine squared theta equals 1 minus cos squared theta. You definitely should remember that one. So 1 minus cos squared theta means that cos 2 theta equals 2 cos squared theta minus 1. And we're going to substitute that in for here. So 2 times, in brackets, 2 cos squared theta minus 1 minus 2 cos theta plus 2. And we can see that this plus 2 is going to cancel out with this minus 2 here, and we'll be left with 4 cos squared theta minus 2 cos theta. Exactly what they wanted. That's lucky, isn't it? Cool. As required. Give yourself a nice big tick. Feel amazing about yourself. Go on to the next part of the question. Let's do it. Yeah, they want you to solve a quartic equation next. Little bit interesting the way the mark scheme chose to do this one. Not that I cheat and look at the mark scheme, of course. I'd never do that. Right. Yeah, so not the best way, I think, that they did it. I'll talk through my method, I'll talk through their method as well, just in case you looked at the mark scheme and got a little bit confused, because that's what I did. I got a little bit confused when I looked at the mark scheme. Okay, let's write out the equation. Z to the 4, yep, minus Z cubed plus 2Z squared minus Z plus 1. That equals 0, and we've got to solve that. Hence, the clue there is hence, so we're going to have to use one of the previous parts of the question. This equation looks very similar to the equation we just looked at in the previous part. The only difference is we've divided everything by z squared. Just before you do that, you have to stop and think, when you divide by things, are we dividing by 0? Can z ever be 0? Well, one reason we know z can't be 0 is because the argument of z is 1. So that's it lies somewhere on that unit circle. It can never be 0. But the other thing you can do as well is you say, if z equals 0 here, what are we left with? Oh, we're left with 1 equals 0, which isn't true. So z can't be equal to 0. That means z squared can't be equal to 0. So we can divide by z squared. We're not going to destroy the universe if we do that. So dividing by z squared means we have to solve this equation. Z squared minus z plus 2 minus z to the minus 1 plus z to the minus 2. That equals 0. Now, what they do in the mark scheme, although they don't write this step down, what they do in the mark scheme now is they factorise this. I did figure out how they factorised it. Yeah, they factorise this into z plus 1 over z, but they don't quite make it clear. So if you're confused, this is what's happened. Times z plus 1 over z minus 1. So they factorise now that into that, which I don't think is an obvious factorisation. Maybe, if it was a show that question and they'd given that, yeah, maybe. I don't think that's an obvious factorisation now. I'm going to do something that's a lot more sensible, because from part 3, from A part 3, we know that this is equal to 4 cos squared theta minus 2 cos theta. So we need to solve this is equal to 0. And that's just really C1 or C2 until you get to the very end, because it does say you have to write it in the form A plus BI. So how do we solve this? Like I said, C2. Let's divide both sides by 2 and factorise out the cos. That gives us cos theta times 2 cos theta minus 1. That equals 0. So that means cos theta equals 0. Or cos theta equals a half. And these are all common angles. So cos theta equals 0. That means that theta is plus or minus pi on 2. And cos theta equals a half means that theta is plus or minus pi on 3. Cool. And the only thing that's left is to write it in the form A plus BI, like they said. So remember, z is equal to e to the I theta. So our 4 solutions will be e to the plus pi on 2, pi I on 2. And so on our Argand diagram, that has argument 1, modulus pi on 2, 90 degrees. So that's just here, that equals I. Similarly, e to the minus pi on 2, I is minus I. So we've got one solution there and one solution there. And e to the plus pi I on 3. Well, there's no easy way of seeing this on an Argand diagram, really. Pi on 3 is 60 degrees, so it'd be about here. Again, like I said, it must lie on a unit circle. So there's no easy way of seeing what that is. So to write it in form A plus BI, let's just use that and use the cos theta plus I sine theta form, and then work out our common angles. So this would be cos pi on 3 plus I sine pi on 3. And like I said, those are both common angles, so you can work out what that is to get your third and fourth solution when you chuck minus pi on 3 in as well. Cool, okay, not too bad, that question. Like I said, the mark scheme did the last part in a bit of a confusing way, so that might have tripped you up. And, but I think important to remember, if you can't do A part 3, if you can't see the factorisation or whatever, doesn't matter, still go on to part B, because it says hence, and it's giving you the result in part 3. It gives you the answer to part 3. So even if you can't prove it, just take the answer and go on to the next question. No, not much else to say other than that, I think. I'm going to stop this video now and make a new video, I think, for question 7. And the only reason I'm doing that is because I might get more views. I thought that way, having 2 videos rather than 1. Yeah. Okay, so if you want to see question 7, watch the next video.